Alright, this video is for our CS 172 class, York College, trying to do proof by induction for adding consecutive numbers. Um, but alright, so before I get into the proof, I just wanted to cover up some quick background. This is a quadratic function, right? We know it's a quadratic function because the highest power here is 2. And what I want to do is solve this by factorizing, because we'll use that, or we'll use some of those principles when we get the proof by induction. So if I take the first number 3, right, multiplied by the -4, right, I get 12. And then two numbers, when I add, I'll get -4, right? And then when I multiply those two numbers that I add, I'll get -12. So essentially what I want to do is expand this -4x. And what I'm doing to do that, I'm multiplying the 3 by the 4, that is the first by the last number. That'll give me -12. And I'm saying that -6x plus 2x will give me 4x. And -6 by 2 is -12, which is the same number that I got when I multiplied the first and the last. Here, so now I factorize. The number that is common between the 3x squared minus 6x is 3x, and common between 2x minus 4 is 2x. I have those on the outside. And then in the inside of each bracket, and I know that it's correct because I end up with the same number inside of the bracket. Now this part here is what we will refer to later on when we get to proof by induction. So I know that the 2 is x minus 2 is similar, so I'm good, it's correct. And when I factorize, this is what I'll get. I'll take the 3x from the front plus the 2x plus the 2x, put that in one bracket, and then use one of the x minus 2 in the other bracket. So hopefully we're okay with this. If not, again, anything that you don't follow on the video, just bring it up again in class. We could work on it. Now the next thing that I wanted to look at, right, is when you have a function f of x. In this case, we have f of x is equal to 3x squared minus 4x minus 4. When you have that function, you'll say you could substitute anything for x. So if you say f of x plus h, then what you're doing essentially is you're substituting x wherever you see an x in the equation with x plus h. So in this case here, I have 3x squared. So here I'll have 3x plus h squared. I have minus 4x squared minus 4x plus h. So wherever there is an x, I'm substituting that with x plus h. So, you know, you just f of x, you just substitute it. Alright, so now this brings us to our proof by induction. Alright, so we have two steps. First, you want to prove it with 1, then prove it with 2, and then prove that n+1 it should work for, and if it works for 1, if it works with 2, then it should work for n+1. Now, I'm not going to do 2. I'm going to jump to a different number. But in the exam or whatever, you can use 2. It's going to be the same. It's the same principle that applies. So in this case, f of 1, right? So remember in the last section I said, whatever you have f of whatever, right? Wherever you see n, you'll substitute it for the 1, because we're doing f of 1. And when we do that, we get 1 plus 1 is 2. 2 by 1 is 2. That'll give me, so here, when I use 1 in the function, I'll get 1 as my answer. And then if I were to add two consecutive numbers starting from 0, 0 plus 1 is equal to 1, which means that it works, right? Now, here we have f of 3. 3, so we're just going to substitute 3 for n, and we're going to we're going to uh, we're going to substitute 3 for n and put, oh, sorry, I was distracted there for a moment. Let me go this again. We're going to substitute 3 for n. Here we have, wherever we see n, we'll put 3. 3 plus 1 divided by 2. That will give me 3 times 4, 12. 12 divided by 2, that will give me 6. Now if I add, oh, wait, 1, 2, 3, yes. 1 plus 0 plus 1, 1, 1 plus 2, 3, 3 plus 3, 6. So we see that it works, right? Now, I'm going to do it for 10, just so that, as an extra step to see if it works for 10. So f of 10, 10, wherever I see n, I'm substituting with 10. F of 10, 10 plus 1 divided by 2. 10 by 11 divided by 2, that's 110 divided by 2, that's equal to 55. If I add all the numbers from 0 to 10, I should get 55. So I got 0, 1, 3, 6, 10, 15. So that's 15, 15, and 6, 21. 21 and 7, 28. 28 and 7, 36. 36 and 9, 45, and 10, 55. So we see that, whichever number we use for this function, it works. Now, this is the part where I think we want to, where we want to get to. Again, n is any number that you can choose. Not any number, any whole number. Any number from 0 onwards, right? But how do you move from 1 to 2, or from 2 to 3, or from 3 to 4? How do you move how do you move along that line? Essentially, we're saying that it's n, or any number, plus 1. So that's how we're getting the n plus 1, because we want to move from, we want to jump from one number to the next. And the only way to do that is to add 1 to the last number, or to the number that you're on right now. So here, so that's how we end up with n plus 1. So, and remember, it's not this n plus 1 in the equation. It's where n is equal to n plus 1. So remember earlier we said x plus h. Here we're saying f of n plus 1. So wherever we have an n, we're going to substitute that with n plus 1, right? And then we keep the plus 1 here, right, from the original function, divided by 2. So this is our proof. This is what we want to get to. Well, at least part of the proof. This is what we want to get to. So here we have, this is what I was explaining just now. How this is our n. All of this, any number, n. But we want to get n plus 1 is essentially your next number, moving from n to the next number. So that's how we ended up with that n plus 1 over there. So f of n is equal to n plus 1. That's our original, that's our current number, where we are on the number line. And n plus 1 is the next number. So we want to add these two together. So that's going to be our proof by induction. Adding these two, n plus 1. Essentially, if it's too confusing, or if you find it a bit confusing, the concept behind it, just all we got to remember is n, open bracket, n plus 1, close bracket, divided by 2, plus n plus 1. That's it. Add those two together, and that's what we're going to come up with. So we're going to do, I'm just going to switch this around. I'm just going to switch the what's on my left side of the screen and what's on my right side of the screen. That's all this is. Alright, so here, n plus 1 divided by 2 plus n plus 1. So when I work that out, I have, this is essentially what it comes out to, n plus 1 divided by 2 plus n plus 1 over 1, right? Because there is no, the denominator in this case, in the n plus 1 on this side, is is 1. So our common denominator is 2, right? 2 into 2, 1. 1 times my original thing up at the top here, that will give me n plus 1. N plus 1. 1 into 2, 2. 2 multiplied by my numerator, right? So 2 times n plus 1. So that's this. Now, when I work this out, you see here, comes back to where we were in the first place with the f of x. This is the same as before, as when we did the quadratic function before, right? So if you notice here, n open bracket n plus 1 plus 2 open bracket n plus 1 is the same as is what we did before when we did the factorization. So 3 open bracket x plus x minus 2 plus 2 open bracket x minus 2. If you notice, the n plus 1 in here is the same as the n plus 1 over here. So, that's what I'm saying with this next line. So when I factorize this, remember we did the factorization earlier. When I factorize this, I'll get n, and I color coded it so you'll see which one. The red n comes down, and then n plus 2 on this side divided by 2. So this is my equation here, right? This is the same. Both of these are the same, and I'll show you. Because n plus 1, that's the n plus 1 on this side here, right? N plus 2 is the same as n plus 1 plus 1. 1 plus 1 is 2, right? So that's basically, I said the same thing again. All right, n plus 2, that's what I'm saying here. N plus 2 is the same as n plus 1 plus 1, right? And that's the proof by induction. We end up with the same thing. All right, hopefully that helps. Feel free to look at it multiple times, and then whatever questions you have, let me know.